In this video, we'll make a WPF calculator app that features all the basic functions you'd expect, using the opportunity to also explore some C# tips and tricks and user interface design with XAML. Hey guys, and welcome to Tool Coding. To save time, I've gone ahead and set up some of the UI controls we'll need to make our calculator, and I'll talk you through those in just a moment. All the code in this video is available from the link in the description down below. I'll be writing this in C# today, but there's a VB.NET translation available from the link as well. Let's start by exploring the user interface. I've created several buttons including the numbers, mathematical operators such as add and minus, a decimal point and backspace button, and a clear, plus minus and percentage button at the top. I then arrange these in a grid like so. You can specify how many rows and columns a grid has with these row definitions and column definitions. Then when we want to place a button in a grid cell, we simply specify the row and column index. To avoid having to repeat the styles for each of these buttons, for example the background color, text color, etc., we can create a style that we reference using the static resource markup, and then in the window of resources I define the styles. In the number button style, for example, I've defined each property using a setter, specifying the property name and value. We can then set the template for the button, which will contain the text content through this content presenter. We can also reference properties we set earlier using a template binding, like I've done for the backgrounds here. If we wanted to add a mouse over effect, all you need to do is add in this trigger and override any property you like, so there's no need to go into the code behind to do this. And for the other button styles, instead of repeating all the property setters above, I've based these styles off the first one using the based on property, overriding the relevant properties like font size and colors. Now we cover the interface, let's add in the basic functionality. Each of these buttons has a click event handler attached to it, and I've gone ahead and created the functions for these in the code behind, which can be done automatically in Visual Studio. Up the top I've got some variables to manage the current input and operation, as well as the first number that was entered before the operation. We also have two boolean values to check what state we're in. When the user clicks on a number button, we can get the number they clicked on using the sender variable's content property. Because this content property could be null, I'm just going to add a null check to avoid a warning in the IDE. Then we're either going to append the number to the one on display or replace it entirely. We'd replace it when it's a new calculation, the number on display is 0, or the user has just pressed an operator. And don't forget to update the text property afterwards. When the user presses one of the operators, we'll get that operator from the button as before, and then make sure the user hasn't just chosen an operator. For example, they might click add and then change their mind and click multiply. So if that's not the case, we'll check if we have an operation set already. If we do, that means the user has done something like 2 plus 2 plus, at which point we'll want to add up 2 plus 2 and display that result. Or alternatively, we'll just make a note of the first number they input. Then we can update the operation in any case and set is operation just pressed to true. In the equals button click event handler, we'll calculate the result if we have a valid set of numbers to work with. Now for the most important function, calculate result. As you saw earlier, we have a variable that stores the first number, so let's get the second number from the current input. And then we'll use a switch statement, which is a more readable way of managing multiple conditions. The calculations are fairly intuitive, but one important thing to note is that we can't divide by 0, so I'll add in a message box if that's the case. Then we'll set the result and first number, and run the application to see how it works so far. If I try a simple operation and click on equals, that gives the correct result. And I can also continue with a second operation. We'll now finish things off and add in the additional features and enhancements. We can start off simple with the clear button that just resets all the relevant values. And then we'll move on to the decimal button. If an operator has just been pressed, that means we're typing a second number, and so we'll update the text to say 0 followed by the decimal point. And otherwise, if it doesn't already have a decimal point, we'll add one on. Of course, if there's already a decimal point on display, we shouldn't add another one. The delete button will simply backspace against the current number on display. To do this, we first want to make sure no operator has just been pressed. The input has a length greater than 0, and it's not a new calculation. If that's all good, we can use this handy notation to delete the last character from the input string, and then we'll want to set the result to 0 if it's now become empty. The percentage button is just a shortcut to divide by 100, so let's divide the current number by 100 if we're in a valid state. And lastly, for the plus minus button, which allows us to write negative numbers, we'll first check for a valid state, making sure the number isn't 0. If the input starts with the negative sign, we'll want to remove it using the square bracket notation from before, and if it doesn't, we'll add it on. Let's test it out. I can type in a decimal number, backspace one of the values, make it negative, and perform a calculation as before. And I can use the percentage button and the clear button as intended. But notice that I can type a really long calculation and it flows off the screen, So let's fix this by accounting for long numbers. Firstly, we'll want to prevent the user from typing a really long number in the first place. We can do this by checking the length of the input and returning early in the number button function and decimal point function. Even after doing this, we can still end up with a long number on display. So in the calculate result function, we'll want to check if the result is reasonably long or short, and if it is, we'll output the result using scientific notation like so. You might be familiar with how this looks. It's a number like this with the letter E, which essentially means a number times 10 to the power of another number. Lastly, we want to account for long decimal numbers such as recurring decimals. If the number contains a decimal point and has a length greater than 10, we can round this to 8 significant digits, and otherwise we'll just output the result as a string. Let's test this out by dividing 10 by 3 and multiplying this by a large number. Here's a bonus task that you can work on. See if you can add the current operation into the operation text block here. The operation should be something like 2 plus 2 when the answer of 4 is shown below. If you're looking for some example apps, I've created a suite of desktop and Android apps that are all open source, and check out Applets to brush up on your language skills for free. All the links will be in the description down below. Be sure to leave a like if you enjoyed this video and subscribe to keep up to date with the latest from Visual Coding. Thanks for watching and I'll see you soon.